Welcome back, everybody. So we're starting here with question 7 from the section 2-4 homework. Let me screen capture that in. Let's go to a new page. Why not? Are we there? We're there already. Perfect. It's running smooth today. All right. So this is quite similar to the question that we did in class yesterday, right? Even so far as we're going to have to graph this in the end. But let's kind of prep it. We need to figure out. Now, this is telling us to do two different things, right? Don't confuse this. This is not one single problem. This is actually two different problems because I want to know, okay, for epsilon is 0.2, and then separately, okay, do that again with epsilon is 0.1. That's what this is saying. All right, so what does that mean? That means that I want to say x cubed, the absolute value of x cubed minus 3x plus 4 minus the true limit is less than, we'll start here with 0.2, right? Which means I need to fall between this piece here, x cubed minus 3x plus 4, 6.2 and 5.8. Forgive me for skipping a couple steps there. I'm adding the 6 over and putting the 0.2 and the negative 0.2 on either side. But that's truly what this epsilon of 0.2 means. I'm adding the 6 here, that gives me my 6.2. There would be a negative 0.2 on the other side, and if I add 6 to that, it's 5.8. So I've got 5.8 is less than x cubed minus 3x plus 4 is less than 6.2. Okay, so those are the values that I'm going to be looking for. All right, so now we just got to go to our calculator and manipulate it into solving for that. Let's go into our y equals. Okay, this is very similar to the problem that we did, but now I'm going to do minus 3x and then plus 4. I know I want to do 5.8 and 6.2. We all follow me here? Just put in your two y values. Let's zoom 6 this. Okay, so I know I want to go to x's too. So maybe zoom box might be good. Z box. So let's go up here. Let's try to get it real close in there. Okay. Let's see what we got. Yoinks. Okay, perfect. Second, calculate the intersection point above. First curve, enter. Second curve, sure. Guess there. Okay. Same thing. Second, calculate intersect. First curve, just got to make sure. Oh, okay. I want that line. I want that curve. Good. And intersection, whatever it's going to see it. Okay. Come on. There we go. All right, so those are my two x values that's going to make that happen, right? Those are the two x values that are going to make it happen. 1.97 and 2.02. Let's actually round to the nearest, because they're so close. Let's round to the nearest 1,000. Let's go 3 decimal places in. 1.977 and 2.022. Now, what's going to be closer, the 1.977 or the 2.022? Well, I mean, just take it away from 2, right? Because that's what we're aiming for, right? Take it away from 2. So 2 minus 1.977, extra 7, is 0.023 away. Well, how much is this one away? We got a winner, right? So the delta here would be 0.023 away, and the delta here would be 0.022 away, right? And actually a little less than 0.022 because I rounded up, and a little bit more than that because I get whatever. So I'll always choose the smaller delta, right? So my delta is going to be 0.022. Always choose the smaller delta. Questions about that? Okay, how would this change when I want to do epsilon of 0.1? Well, I would honestly just go back into my calculator and go to my y equals. Instead of 5.8 and 6.2, let's do 5.9 and 6.1, because that's going to give me a little bit more narrow of a focus now. And now when I run those x values, well, I just do the exact same thing. I calculate and then find the smaller value of delta. Does that make sense? Okay. All right. What other questions do we have for this here? Yeah.
Either 20 or 21.
You want me to just do one of the proofs?
Yeah.
Okay. I'm going to look at my key and do the easier one. Because you gave me the option. Hold, please. 2, 4. You want 20 or 21?
Of course. Okay.
Oh, I'm definitely doing 20. Okay. You gave me the choice.
Somebody else asked for 20.
No, I'm only doing one of these. I'm only doing one of these. Suckers. I mean, I do. I mean, I do.
Yeah.
But there's something in this that you should know.
Okay, I'm gonna do it.
There's something in this that you may not know, and that it's a good thing that I'm doing this. So I want to prove that this limit is -5, right? So let's prep this by saying, okay, we want the absolute value of x minus 10 to be less than delta, right? So that's what I'm looking to find in there, right? That's the piece that I'm looking for. And where am I going to look for that? I'm going to look for that within this. Okay. 3 minus 4/5 x minus a -5 is less than epsilon. Everybody follow me there? Okay, so let's reduce that down a little bit. Well, that would be 3 minus 4/5 x plus 5 is less than epsilon. Okay, 8 minus 4/5 x is less than epsilon. And then, ooh, how are we going to get a 10? Well, ooh. You know, what does the coefficient on x have to be? 1, right? The coefficient on x has to be 1, because I'm looking for this. So maybe we should factor out a 4/5. Maybe we should factor that out. So if I factor out a 4/5, well, when I factor out a 4/5, that would be like taking to factor out is to divide out, right? So that would be like saying, come on, calculator. That would be like saying 8 divided by 4/5. And look what we get. Uh-oh, bingo, 10. 10 minus x. Okay. That's weird, right? One thing that you may not know, that the book assumes that you do know, I'll put it in green because it's weird, is that the absolute value of a minus b is equivalent to the absolute value of b minus a. Okay, that is just a rule for absolute values that always works. You want to use 3 and 5. 3 minus 5 is -2, but the absolute value turns it +2. 5 minus 3 is +2. The absolute value keeps it +2. Does that make sense? So you can use that rule. Now, how does that help us here? Because 10 minus x is the same as x minus 10 when looking at it in an absolute value. So what I can do here is say this. This is actually going to be 4/5 of x minus 10 is less than epsilon. That's the part that you may not know. You may not have known how to do. And the dividing out the 4/5 is kind of weird too. All right, so let's solve for epsilon, or solve for x here. Let's divide over the 4/5. So that means the absolute value of x minus 10 is less than 5/4 epsilon, right? Multiply by the reciprocal. Keep, change, flip, if you will. So that means, what is my delta that I'm going to choose? 5/4 epsilon. Right? Delta is now going to be equal to 5/4 epsilon. Okay, so we found our delta. That's kind of like half the battle. Like, I'm going to be really lenient on making sure that you're stating everything in your proofs. Like, I know that geometry teachers would cringe at me saying that, but really the important part about this is figuring out what your delta is going to be. If you get here, you're on a really good track. Okay. All right, so let's actually state the proof. Okay. We are given, and we have to start this by saying we always have to say epsilon is greater than 0, and we're going to choose. How did we do this yesterday? I felt like there was another statement in there. Choose that delta is equal to 5/4 epsilon. Equal to 5/4 epsilon. Didn't we say, and the absolute value of x minus 10 is less than delta? I think that we said that. Was that? All right. So again, we got to start working backward on these, right? We know that 3 minus 5/4, 4/5 x plus, you could say minus a negative 5, but I'll just put that as plus 5, is equivalent to 8 minus 4/5 x, which was equivalent to 4/5 absolute value 10 minus x, which was equivalent to 4/5 x minus 10. Kind of like working our algebra backward there. Now, we know that is less than, oh yeah, we did need this up here, because look here, 4/5 x minus 10 is less than 4/5 delta, right? If I just do this right here, I can do that on the same side, right? That's not really part of the proof. That's just so we can visualize, well, that's got to be less than 4/5 delta. Now, what is 4/5 delta? Well, 4/5 delta is equivalent to 4/5 times 5/4 epsilon. So that's equivalent to epsilon. So 4/5 delta is equal to epsilon. So now we can say, chain it together, this, which was, what was that? That was f of x minus the negative 5. I guess I should have started with the minus the negative, just to be very clear. I know we all know that's a plus, but whatever. Is less than epsilon. Okay. Chain it together. This piece is less than this piece. Because we know 4/5 delta was equal to epsilon, so we can say this whole chunk from the beginning, which is f of x minus negative 5, f of x minus L, is less than epsilon. And there's always the end of the proof. Because again, within the prep part of the proof, I see all of that work, right? So, I know I'm your math teacher, so I read it that way. But again, in a proof, you're always looking to write it as if you were explaining how to do this from anybody's perspective, even a non-mathematician's perspective. Questions about that? All right. Well, I'd like to go over some problems. Is that okay? I just threw these kind of up here, and let me do this. Let me pause that up there. Oh, you know what? Nah, I'll just talk through those. You want to work on some, and then we'll get back to it? I'll give you just a 15 minutes. You want to work on those? And then we'll reconvene. Is that okay? I'm going to pause the video real quick so they don't have to sit through 15 minutes of silence. Play. And we're back.
2x.
Okay. Can I do direct substitution really for any of these? No. So I've got to manipulate it before I do direct substitution. That means in the numerator of number 1 here, what's that factor into? Minus 5 plus 1, right? No, minus 1. All over x minus 5. Presto changeo. So 5 minus 1 is 4. Not too bad, right? Now, same thing on the right on number 2 here. However, I know like for a lot of you guys, it's like, wait, how do we factor that? Wait, what are we doing? So that's why I wanted to do one like this. It's been a minute. So x squared minus 3x minus 4. Well, that turns into x minus 1 x plus 1 x minus 4. Correct? Yes. Again, I'm doing these cold, so make sure if I do something weird, say, hey, wait. Let me move this so I can factor this right underneath it. Okay, now remember, can I just go straight to my 2 parentheses? No. This is a hard type one that I would call it to my algebra 1 students. A hard type factoring where there's a coefficient out in front, right? I know Mr. Delap likes to do guess and check, and actually this one might be quicker to do guess and check if you're a good guesser. But I do the factor by rewrite method where I say, okay, 2 times 3 is 6. What are the factors of 6 that add to the middle? 5. 2 and 3. Right? 2 times 3. Right? So I know the factors of 6. You always do A times C, first times last, and that'll get you your they call it the master product method. That'll get your master product. And then you say, okay, what are the factors of that master product that will add to get to the middle number? Now, the only issue is now we have to do factor by grouping. 2x squared plus 2x plus 3x plus 3. That 5x gets broken up into these 2 pieces, right? Well, let's factor by grouping now. We pull out a 2x, leaving an x plus 1. We pull out a 3, leaving an x plus 1. So now I know that this factors into x plus 1, and then my leftovers, 2x plus 3. Remember, that's how you factor ones with an a out front. Yeah?
How did you get to 6?
You take first number times last number.
Okay.
6. And then you say, what are the factors of 6 that add to get to my middle? So my middle is 5, right? So I picked 2 and 3. Does that make sense? All right, so now, once we get to this part, it's like, oh, cool. So long, farewell. We've got the limit as x goes to -1 of this thing, x minus 4 over 2x plus 3. And let's see what we get. -1 minus 4 over 2 times -1 plus 3. So -1 minus 4 is -5. And then that would be -2 plus 3. Oh, cool. 1. -5. Ooh, I made that come out real nice. Sweet. Questions on that? Yeah, I would venture to guess that the hardest part about that was factoring. That one at least. Let's take a look at numbers 3 and 4. All right. Anybody remember what I need to do for this one? Good. Yeah, multiply by the conjugate, right? Yeah, multiply by the conjugate. So this was that 16 plus h minus 4 over h. I'm going to multiply it by radical 16 plus h plus 4. Radical 16 plus h plus 4. Okay, multiplied by its conjugate. Okay, now when we do that, we FOIL this here. So first, well, that's just 16 plus h. Outer is 4 radical. Inner is negative 4 radical. So what happens with my outers and inners? Cancel. And then our last, negative 4 times 4 is minus 16. And that's still multiplied by h times, and I don't want to distribute this in, and you'll see why here in a second. 16 plus h plus 4. And you may already be able to see it. The 16s will cancel, and then the h's will cancel, won't they? The 16s cancel to get just an h in the numerator, and then the h cancels. So we get 1 over radical 16 plus h plus 4. And then if I want the limit to go to 0, we'll just plug in 0 now. So this is 1 over just radical 16 plus 4, which is 4 plus 4 is 8. 1/8. Questions on that one? Let's take a look at this one right here. Let me move you down as well. Go. Okay. Let's take a look at number 4. Now, can I just straight up plug in 3? Rats. Man, that'd be nice. What if I threw one at you like that? Just like throw you a bone. All right. So what do I have to do here? Well, looks like I've got to get common denominators up top, right? So let's just do 3 up here and x over x. Yeah. Let's see what that does. That gives me 3 over 3x minus 1 minus x over 3x. All still divided by x minus 3. You follow me so far? Just getting common denominators up top. And that would be 3 minus x over 3x, all divided by x minus 3. Now, the nice thing about this is watch what I can do. I have 3 minus x over 3x. Keep, change, flip. And it's like, oh, I really want to cancel that. Oh, wait a sec. If I just flip this around, that's equivalent to saying negative x plus 3 over 3x times 1 over x minus 3. I can factor out a negative there. Can't I make that negative x minus 3? Yeah, I can. So now I can do that, which means I have a negative 1 over 3x. And the limit as x goes to 3 would be negative 1/9. Negative 1 over 3 times 3, negative 1/9. Sweet, I made some good problems. These are good. These are coming out like nice and even. I'm not getting like negative 500 over 72 or something. All right, we good there? Okay, now let's take a look at this piecewise one. Now, all I'm asking you to do here is find the limit as x goes to negative 2, and then separately find the limit as x goes to 7. Now, remember that the limits have to match up. Left side limit must equal right side limit whenever you're looking at anything piecewise. So for the limit as x goes to negative 2, for this to exist, I must calculate the right side limit and then the left side limit separately to see if this exists and where it's at. So what would be the right side limit at -2? Well, what rule would I use? 2x plus 7, right? Because that's going from the upper side of -2. So we would say 2x plus 7 here. Well, in that case, that's equivalent to, I'll just put an equal sign down here. That's equivalent to 2 times -2 plus 7. So 3. So the limit on the upper side is 3. The limit on the lower side, now I'm going to be using x squared minus 3. Okay, now that is equivalent to -2 squared minus 3. So 4 minus 3, so 1. What can I say about the limit as x goes to -2? It does not exist. Okay. Let's do that same thing for 7. Let's do that exact same thing for 7. Okay, the limit as x goes to 7 on the right, and the limit as x goes to 7 on the left. All right, on the right, on the upper side of 7, the limit as x goes to 7 from the upper side is just 17, right? Just a constant. The limit of the constant is the constant. Oh, sweet, that was easy. Okay, let's take a look here. Let's plug in. The limit as x, I already wrote that. The limit as x goes to 7 from the left would be 2 times x plus 7. I thought I was going to make this work. Oh, bummer. Oh, well. 2 times 7 plus 7. Well, that doesn't work, does it? That's a bummer. 1421. Oh, so that one doesn't exist either. I thought I made one exist. Sorry. But you get the idea, though. The left side, like if I had, if I changed this problem, which I will for my next period class, and I made this, I guess what would I make that to make the limit exist? 21, right? If I had just made this 21, well then here that would be really quite easy. That would flip that to be 21. And then we would say, oh, good, the limit matches from the left and the right. So therefore, the limit would be 21. Does that make sense?
Yep.
A couple other things. Just looking at graphically, I will be asking you to evaluate some limits like this. I know there were several problems in the homework like this. Just be careful. Like if I asked you to find the limit as this function goes to 0, people always get confused, and I don't know why, when the line just runs through that value. Like, what's the limit as x goes to 0? -4. I always get some weird and wacky answers for that. Okay? Now, does the limit exist here? No. Does the left side limit exist? Yeah, at 5. Does the right side limit exist? Yeah, at -2. But the whole limit does not exist. Remember, because it's got a left side match right side. What if I asked you to find the limit as x goes to -7? If I just wrote it like this, the limit as x goes to -7 does not exist. He said -4. What is that? That's that. Does that make sense?
Yeah.
So be careful with that. No left side limit, no right side limit. For it to exist, left side limit must match right side limit. Yeah. And no limits to infinity. Like this one would be -infinity. This would not exist. This is positive infinity.
I mean, like it's Carlos. I wouldn't choose to